Question and answers on sinusoidal quantities.
Okay, this episode is basically for solving a question under addition and subtraction of the sinusoidal quantity. So without wasting my time, let's take the question together.
Four conductors meet at a junction. The following relationship exists between them. I4 equals I1 plus I2 plus I3. You're asked to find the value of I4 given that I1 equals 5 sine omega t. I2 equals 8 sine omega t plus pi on 3 plus 5 sine 3 omega t. And I3 equals 15 sine omega t minus pi on 4 plus 8 sine 3 omega t plus pi on 3.
So from the question, we are asked to find I4, which is equal to I1 plus I2 plus I3. Okay. And from the question, we're giving I1 as 5 sine omega t. We're giving I2 as 8 sine omega t plus pi on 3 plus 5 sine 3 omega t. Okay. And we're giving I3 as 15 sine omega t minus pi on 4 plus 8 sine 3 omega t plus pi on 3. Okay, so this was what the things we can draw out from the question. And the question says we should find I4 by adding all of these together. So this falls specifically under the addition of this sinusoidal quantity. But first of all, to do this very well, you realize that there are some of the quantities with the same frequency. So if you check this particular quantity, and if you check this quantity, they all have the same frequency. But when we check these two quantities and this, they also have the same frequency, but their frequency differs from the frequency these ones are having. So now what happens is that we solve for them in two different cases. We can't add them together. No. We can add this, and we can also add this plus this plus this plus that. But this and this are having two different phase angles. So that means without the phase diagram, we can't actually tackle this question. So now we have to start with this one, and after we come here. Okay. So now what happens is that with the solution, we want to do with the addition of the omega part. The addition of the omega part. And the addition of the omega part, we have 5 sine omega t, 8 sine omega t plus pi on 3, 15 sine omega t plus this. But before that, you have to draw the phasor diagram. Now this is in phase. So now I1 is in phase. It has no phasor diagram. It has a peak of 5. I2, this part, it has a phasor diagram, and pi on 3 is the same as 60 degrees. And pi on 4 is the same as 45 degrees. You should take note, because pi in radian means what? 180 degrees. Okay. So now, this I1, it is in phase. Now the I2, which is the 8 sign, this part of the I2, is leading because of the positive here. It is leading by what? 60 degrees. Okay. So the I2 here, which has the 8, is leading by what? The peak current is leading by 60 degrees. Okay. Now the I3, this part, that one is lagging by 45 degrees because of the minus here. So the 15 I3, this I2, so the I3, which is the 15, that one is lagging by 45 degrees. Okay. So if you have this, since you have this, we can now go on to add what we have together. But when we take here, realize that you have an y component and you have what? An s component. So you have to resolve this into the y component and the s component, and we add them to find them. Okay. So now, first let's start with finding the x component. Addition of the x components. We are resolving them into the x component. So now resolving them, this is already in the x component, the 5. So it becomes 5 plus. Resolving this 8 into the x component is cos. So if you want to resolve it, that one is cos. So it becomes 8 cos the 60 degrees into the x component, cos 60 degrees. I want to resolve this 15 into the x component, that one is also cos 45 degrees. So plus 15 cos 45 degrees. Now when you do this, you are getting 19.607. If you do this, you are getting 19.607, and that is the x component. Now when you come to the y component, resolving them, the vectors in the y component. So now we are resolving all these vectors in the y component. This cannot go in the y component because it's already in phase, it has no angle. So it is 0. So the I1 is 0. Plus, this can go in the y component. It has a remaining of, I think, 30 degrees. So it can go in the y component. So if you want to resolve that in the y component, then using the 60 degrees, it still maintains at 8 sine 60 degrees in the y component. Now the 15 is still 45. So resolving this also into the y component is minus, this is the y component here, so we are resolving it here. So here is plus and here is a minus y. So if you are resolving it here, that one will give you a minus 15 sine 45 degrees. Because if you draw a Cartesian plane, here is plus values of the y and here is minus values. So if you want to resolve this to this side, this y is minus. So now when you solve this, you are getting negative 3.678. Okay. And this is only the addition of the omega part because they have the same frequency. Okay, so now when you do this and you want to find the amplitude, after doing this, you would like to find the amplitude of the omega part. That is the peak current. So the amplitude here, that is the I. Want to find the amplitude, the peak current. How do you find it? You have the x and have the y. So the resultant amplitude now becomes, the 19.607 squared plus negative 3.678 all squared. Okay, so now how do we get that? We got that because the x component here was, the x component here was 19.607 and the y component was negative 3.678. So if you find the resultant, that will give you what? The resultant line will give you this, the peak voltage. Okay. So if that is giving you the peak voltage, and you do this, you point this on in your calculator, you are getting 19.949. When you do this, you get 19.949. Now, how do you find the phase angle? Find the phase angle. So the same way like the diagram I drew in the x direction, that was 19.607, and in the y direction, which was negative 3.678. And you want to find the phase angle. The phase angle. So if you join these two together, this is it, the phase angle. So the phase angle, we want to know how they are lagging. So that will give you a theta, which is equal to tan inverse of the opposite, negative 3.678 divided by the adjacent, 19.607. And when you do this, you are getting negative 10.62 degrees. Negative 10.62 degrees. So what it means is that the first aspect, when you add this, the whole of this, so you are adding I1, I2, I3, but adding that aspect of one, the omega, because they have the same frequency. So now therefore, the I4, that is the first aspect of the I4 will be for the one with the same frequency. So that I4 now will have a peak voltage of 19.949 sine into bracket omega of, now this one is lagging. Are you getting it? So this one is lagging. If I change it, the direction this way, and this one comes this way, -3, and this will be it. Here will be the phase angle. So you realize that it is lagging. Are you getting it? This one is lagging. So it will be minus what? It even gave you the whether it's lagging, then give whether it's lagging or it will be leading. So the minus shows that it's lagging. So that is minus 10.62 degrees. But it has not ended. This is the first part of the I4. Because when you add the three of this, you get an omega part and you get an 3 omega part. So you have to now solve for the 3, add these two together. Because you have to add them separately because of their difference in their. These two have the same frequency, but their frequency is different from these 3. So now I'll clean this and I'll leave that one and we solve for the addition of the 3 omega part. Okay, so now we are done with this first part. So you have to also add these two parts and we add it to get the full I4. So the addition of the 3 omega part. Okay, now the addition of the 3 omega part, they have the same frequency. So now you have 5. So here the phase angle is 0. This has a phase angle of 60 pi on 360. Okay, so that means if you want to draw it, it's only I2. So I2 will now be in phase. It has a peak of 5. It will now be in phase. But I3 will be leading by 60 degrees. It has a peak of what? Of 8. Sorry. So I3, it has a peak of 8 only. I1 has no 3 omega, so it's not part of this particular addition. Okay, so what do you do here? You go to the same procedure. You have to find the x component. So finding the x component is also very simple here. The x here, you have to resolve this into the x. So that will give you 8 cos 60 plus 5 already, which is already in phase. Now when you do this, you are getting 9. Okay. So that's 9.00 or what? And you have to also find the y component. So now, finding the y component, you have to resolve the whole of this. So this one has no angle. So when you resolve it, it gives you 0 in the y component. This one you can resolve it. That gives you 8 sine 60 degrees. So when you do the 8 sine 60 degrees, you are getting 6.928. Okay. So now you find the amplitude or the peak current. So now find the amplitude or the peak current. So that one will give you Im, the magnitude here, that gives you Im times. So now the S component. So the square of the S component plus the square of the Y component. So we get here 9 squared, that is the S component plus the Y component, which is 6.928 all squared. Now when you do this, you are getting 11.358. You are getting 11.358. Okay. Now you have to also find the angle. But how do you find the angle? So now what happens is that the x was in phase, the x is here, which is 9, and the y is also here, which was 6.928. So upon finding the angle, it follows this direction. So the other the angle, you put the angle here. So what happens here is that this angle now becomes tan inverse of 6.928 all on 9. And when you do this, you are getting 37.59 degrees. So now, what happens is that this one is leading this. So the value, sometimes when I'm solving these questions, the value of the angle you get will show you that it is either leading or lagging. Okay. So now, since you have the angle now, we can write this side. So this side, the I4 for the 3 omega part now becomes what? The peak, which is 11.358 sine into bracket 3 omega t, the omega part, plus 37.59 degrees. So now the total I4, because the question says you should find I4. So we add the omega part and the 3 omega part for all these i's to give you I4. The total one is simply adding these two together. So we get 19.949 coming my matter. Okay, 949 sine, this is the omega part, omega 62 degrees plus 11.358 sine 3 omega t plus 37.59 degrees. Okay, and this brings us to the end of this very calculation. I urge you to get more questions, and I believe you become familiar with it. Thank you very much.